So in the last lesson we looked at truth tables. This time we're going to have a look at circuit diagrams. So inside the heart of the computer lives a lot of little circuits that allows you to evaluate Boolean expressions. You need to be able to draw the circuits and evaluate the circuits using the symbol shown. The first gate we need to know about is the AND gate. The reason that I remember it's an AND gate is because the AND gate has a capital D, which looks like the AND gate. The OR gate, for some reason in my head, is when you type OR this way and you flip the OR gate, it looks like an R. And then the last thing is the NOT gate. And I like to think of it as it's saying you do not want to touch me because I am pointy. And that's how I remember it. The NAND and the NOR are the same as their counterpart. They've just got a little circle at the front, and the exclusive OR has an extra line at the back. Right, one question you could be asked is to give the output of a circuit diagram. So the first thing I do is I identify the components. So here we've got a NOT gate, here we've got an AND gate, and at the front we've got an OR gate, and then I think about tracing them. So I draw a table. And I know I've got 2 inputs, therefore I have 2 to the 2 outputs, which is 4 possible combinations of things that could happen. I could have 2 zeros, I could have a 1 in A and a 0 in B, a 0 in B, no, a 0 in A and a 1 in B, or I could have 2 ones. Then I trace them. So if an A was 0 and a B was 0, remember that when it goes through the NOT, the input is flipped. So I've got a 1 and 0 going into the AND, which evaluates as 0. 1 and 0 going into the AND, which evaluates as 0. So the answer is 0. Next, if I have a 0 in A and a 1 in B, when the 0 goes through the 1, it becomes a 1. And then the 1. So in my top AND, it evaluates as 1. In my bottom AND, it evaluates as 0. When it goes through the OR gate, 1 and 0 becomes 1. So the answer to A is 0 and B1 is 1. This time we reverse it. So when A is 1 and B is 0, this time the top circuit evaluates as 0, and the bottom of the circuit evaluates as 1, and when it goes through the OR gate, again it becomes 1. So when I have 2 ones, they get flipped and they become zeros. So it's zeros and ones into the AND gate, it's 0 and 0, which evaluates as 0. Then if I match my truth table to known truth tables, then I can see that this gate evaluates as an XOR gate. Next, you might have to draw a table. So we've got A and B and C. So I put A and B together and draw an AND gate. And then once I got A and B, I connect it to C and draw a gate. And that's the circuit that corresponds with this. This final scene is an exams question. So what we're going to do is we're trying to trace the circuit as we did before. So we draw a table. And we know there are 4 different combinations: 0, 0, 0, 1, 1, 0, 1, 1. And then we trace it. So 0 and 0 into the AND gate evaluates as 0, as it does to the OR gate. So our output is 0. Now if we put 0 into the A and 1 to the B, once it goes through the AND gate, it still evaluates as 0. And through the OR gate is 0. So again, we get a 0. However, when A is 1 and B is 0, even though the AND gate evaluates as 0, the 1, it goes into the OR gate and we get a 1. Okay, now we need to evaluate. So when there's zeros, we're not bothered. But when there's ones, it doesn't matter if the B exists or not. It's only the A. So the answer to this circuit is A.